Final topic of material that's going to show up on your test, nomenclature. Oops, I don't know what I did there. Got all excited. Don't hit end, hit share. Softboard, starboard. Activity 3, name the following. Do you see there's no H's in this first molecule? Do you see that every H has been replaced by the same atom, being Br? If I can name the molecule without the Brs and then use the prefix per and add bromo right after that, per bromo, that says every possible position has where H used to be has been replaced with Br. I do want to point out there's a double bond here to here. It's the only way to make this thing work. I'll do a quick sketch, but you're not going to get points for it. So maybe I won't do the quick sketch. I'm just going to tell you, there's a double bond between this carbon and this carbon. Otherwise, you're going to have octet violation. So that's between carbons 2 and 3 of how many carbon chain? Here is your tip of the day, tip of the semester. You got rid of 2 of those groups, put both back. This is how you deal with parentheses. Double bond needs to be as low as possible. That's why I'm starting here. It's hept 2-ene. Every hydrogen has been replaced by bromo. You're covered by per bromo, which is a lot better than the UPAC name. It's not better, it's sure easier. UPAC. You want to see the UPAC? This is going to be wild. Every bromine needs a number. 6 of the bromines are on groups. Oh, I forgot the groups. Dimethyl on carbon 6. Per bromo dash 6,6 dimethyl. I totally forgot those. Do you want me to rewrite it? It's all this answer, you know. And you just make sure you sneak that where the little triangle is, okay? UPAC says there's 3 bromines on 1, 1, 1, 1. Comma. There's 1 on 2. There's 1 on 3. There's 2 on 4. 2 on 5. None on 6. 3 on 7. How many numbers did I just write down? More than 10, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Dodecabromos. Wow. Then you're not done. The other group is tribromomethyl, right? And that's on 6. 6, 6. Tribromomethyl. Can't read what I'm writing, huh? There it is. And then you got to say hep-2-ene. Are you starting to feel the per bromo yet? 2-heptene. That little monster can be replaced with per bromo 6,6 dimethyl hep-2-ene right here. Yeah. This whole thing. Yeah. You're only allowed to do that if it's no H's and only one type of halogen. Got it? And the next part is a new entity entirely. We're naming what's called freons. Freons. Or you can call them CFCs. In fact, freon is not appropriate for general use. So I'm going to rename that one C. CFC. What CFC stand for? Chlorofluorocarbon. carbon, which in this case is a freon. Freon. This one, CFC. HFC. We're famous. We're famous. What's HFC stand for? Henry Ford College. Yeah. Hydrofluorocarbon. And there's a rule of 90 that it sometimes shows up as bonus. I'm thinking I'm going to make it a bonus multiple choice question. I'm telling you now. The rule of 90 says, you got these numbers here, right? CFC 13, you see it? What's 13 plus 90? Give me a number. 103. The first number is the number of C's. This is the number of H's. This is the number of fluorine. Okay? The rest is chlorine. The rest is chlorine. So if there's any spots available, you'll put chlorine there. And I don't think there will be a spot available on this one. One carbon, one H, right? I think that's it. You only have 3 more spots. There's an H, that's another 4. So answer C with 3 H's, 1 C with 3 H's. Sorry, not H's. What I mean instead of H's. 3 what's? It's already labeled there. Fluorines. My goodness, I don't know what the heck happened there. Fluorine, fluorine, fluorine. Oh, there is a chlorine, isn't there? Because there's 0 hydrogens and there's a spot left. Guess what goes in the spot? Chlorine. Sorry, I misspoke earlier. That one, great freon. Works exceptionally well for things like refrigerators and air conditioners. They need a substance that can be, has a low boiling point so it evaporates easily when you run hot things over it, like air, hot air. It boils, absorbs energy from the air gets cooler, right? And then that thing evaporates and you send it to the back of the machine where there's a compressor. That's the thing in your fridge that makes the noise. You've heard the noise, right? When the compressor kicks in, the lights flicker sometimes in the older fridges because that compressor takes a lot of juice and it takes that gas that you just made and repressurizes it to a liquid. So you can put it in the front of the machine where you run some hot air on it again and it evaporates and the air gets cold. The only difference between an air conditioner and a fridge, you're inside the fridge when you're using an air conditioner. So just think of a house with air conditioning as a big fridge, okay? And the fridge is just a little fridge. And the principles are the same. You want to cool the air off inside the object. It's your house for air conditioning, and it's a fridge for your fridge. And let's use the rule of 90 here. 135 plus 90. What you got? 225. This is C's. This is H. This is F. If there's any spot left over, which I anticipate no, because it doesn't say HCFC. If it's HCFC, there's a hint there's a chlorine there, but you don't need to know that. You're going to figure it out on your own. Draw 2 carbons in a row. By the way, this was your answer. 2 carbons in a row. 2 H's. I might have an octet violation here. I don't think HCFC 135 exists. I think I made a mistake. Can we put the 5 fluorines down and see where I went wrong? You got to have 3 and then 2, right? There's only 1 spot for an H. And I have a calculation that says there's 2 H's. It's a unicorn. That's okay. let's use our new learning. What is the correct name for this? And I'm going to correct my question. You like 121? 125? Let's see if it works. HFC 125 is the right question because you said you're going to add 90 to that and you're going to get 215. And does that work out? I think it does. Yeah. So there was no mistake. It was always 125. I apologize. There was a mistake. So just get rid of this math because and let's see if we can go backward. Just write down C's. C's looks like they go in the order of C's, H's, and F's, right? And the rest being chlorine. How many C's you got here? Careful. 1, you're right. How many H's you got here? 0. Yeah. How many F's? Okay. So what's 102 minus 90? 12. So CFC 12, or I'll take Freon 12. Okay. UPAC name is just where's the picture? Dichloro-difluoromethane. UPAC. Dichloro-difluoromethane. And let's make sure we separate out these things. There you go. Methane? Very European typo there. And it's methane. There you go. What about this next one? How many carbons? CHF. CHF. I got 2 carbons, and I've got 1 hydrogen and 2 fluorines. Minus 90 equals 92, 103. Is that right? 113. 22. No. 112 will be 22. 122. So CFC, HCFC 122. How come I had to change the initials from this one? Because it's not a hydrofluorocarbon, it's a hydrochlorofluorocarbon. It's got chlorine in it too. I'm not too picky on that. You'll never be graded on this. It'll be strictly the numbers. Okay? Only about the numbers. You don't need to know the initials that go before. And that's it. Why did we have to replace all of the old freons, which were these little guys, with bigger guys? These bigger guys are modern refrigerants and air conditioning chemicals. And the old freons we had to get rid of. How come? Did you know the story? Or it was before you were born, so you don't know the story. Like early 1980. What was happening in this world was terrible. We didn't know until we found out. We can thank the people like in NASA. And they looked at the ozone layer above this planet. And it was getting, like there's an ozone hole in the ozone layer. And that's not good, because ozone protects you from ultraviolet radiation. It absorbs it and then dissipates it as a lower energy that won't hurt you. Ultraviolet causes first a sunburn and then on a repeated exposure, potential cancer, right? And these chemicals, they're not just a chemical that caused that reaction, they were catalysts. One freon molecule up there could destroy thousands of ozone molecules in a cyclic reaction like we see these radicals do. They do radical stuff, yeah. So they replaced them with bigger ones that they don't get up to the stratosphere. They stay down here. Okay. And they're almost as good in terms of cooling, not quite as good, but they're not destroying our ozone layer. And that ozone layer has been fixed pretty much. Okay. And this is people working together in science. It's called the Montreal Protocol. And everybody agreed to it across the planet. You can't get that anymore. It will never happen again that every country agrees to something in this world. We're too polarized. Your generation is our last hope. You need to fix it. Okay. All right. So even while this was happening, countries like China were doing it illegally. They were hiding it. Because the styrofoam you guys are used to, you know that when you buy a box, the thing in a box and it's packed in styrofoam, it's nice and light and it really protects the stuff well, right? And it's a polymer that's very light. Well, how do they get it light? They're making polystyrene and blowing a freon into it as it's being made. And then the freon evaporates. But it leaves all these air pockets in there, so it's light and strong. Then the freon just leaves and goes up where it goes, right? It's terrible. They got caught, and they're conforming a little better now. Let's just say that. And we are done with the things that will end up on chapter 8 on the test. There is more material in chapter 8, but it won't be showing up on your test. So,
What about the first one?
uh-oh, I have a feeling I didn't finish.
First one on the right side.
First one on the right side. We never named the first one. What did I do? Uh-oh. Yeah, we missed one of the molecules. So I am going to, what am I sharing? I don't even know. Stop sharing. Share. We never did per iodomethylene cyclobutene, and I'm glad you did that. So what you do is you draw cyclobutene. And I pull a fast one on you. You didn't tell us where the methylene was because he didn't have to. If you try to put the methylene here, you're going to get 0 points. If you put the methylene here, you're going to get 0 points. And you're going to get a comment, OV -1. You can't put 2 more bonds here. You can't put 2 more bonds here. So you draw your methylene. On one of the 2 positions, you can draw the methylene. And you're not done because you've just drawn methylene cyclobutene. What do you have to add to it to make it per iodomethylene cyclobutene? Iodine. How many iodines on this carbon? 2. How many? Oh, that's a 2. How many iodines on this carbon? Same answer. How many iodines on this carbon? 1. 1. There's your answer. Glad you spotted that. Now I think we're done. Oh, I want the UPAC name? Yeah, you're right. I'm not done. Vous avez raison, monsieur. I said he's right. Okay. So, you ready? Where's carbon number 1 in the ring? It's got to be one of the double bonds, right? 3. And you know why that's better than going the other direction? 1, 2, 3, 4. If I went here 1, 2, 3, 4, it's not as good because that's only 1 group on 4. Okay. And this way I have 2 groups on 3. If I went the other way, I'd have only 1 group on 3. So lower group numbers. Let's not spend more time for a quarter point than we need to. Okay. So we got methyls on 1, 2, 3, 3. 1, 2, 3, 3. Methyls. I said methyls, didn't I? That's crazy. Iodos. That's 4 iodos. Tetraiodo. I know. What about the iodos on the methylene? Tetraiodo. 4 diiodomethylene. This is nuts. I don't even have room to finish. Cyclobutene. Better whip out the highlighter here. Everything's for this molecule. Oh, I messed up on the highlight. Is this even doable properly? I don't want the rule of 90 math inside my highlighter. Not a rule of 90 molecule. There's the question. There you go. Keeping things separate. And gray pen. Keeping things separate here. There we go. Now we're officially done.